Kristen Uhlenbrock. I'm the Executive Director of the Institute for Science and Policy here at the Denver Museum of Nature and Science. I have to say I want to do more breakfast meetings in this West Atrium because this view is absolutely gorgeous. So when I see your eyes look that way, I know you're still listening. This is going to be a really great conversation, both for those of you joining us in person as well as online. We'll have an opportunity for you all to engage with questions throughout. But what we have is an ongoing dialogue this morning for the next hour, where we're going to be talking about solar geoengineering as part of a 3-part series on climate interventions that we're hosting, and this is part 1. We know that the risks of climate change are ever present and increasing. We know that our ability to reduce greenhouse gas emissions and to slow down some of that warming is quite challenging, and we are not doing it at the pace that has been recommended to do it. So in the interim, people are talking about stepping in and intervening. And so that is going to be what we're talking about in this series. What does it mean to actually intervene through both technology as well as nature-based solutions? We can always say we are already intervening, right, in our natural world, that is humans. But here what we're talking about is geoengineering, which some people find quite controversial. Research has been going on for decades around geoengineering, and there are many subsets under that sort of broader term. And we're kind of moving away from what we call some of these other types of interventions instead of just using geoengineering quite broadly. But today, what we wanted to do for this series is talk about solar radiation management, also known as solar radiation modification, solar geoengineering. You may hear people say SRM, that it's just that shorthand acronym for what we're going to be talking about. So we're going to talk about some of the technology, the mechanisms. What are we actually talking about to reflect that solar radiation back up into the atmosphere? And so we'll talk a little bit about that, but more greatly, which is why this panel is here today and I'm excited for, is we're going to talk about all the other stuff beyond that scientific understanding and technology. We're going to be talking about governance. We're going to be talking about the risks, trade-offs, benefits, ethics. We're going to talk a lot about uncertainty in some of these technologies, and that we are. I don't know if many of you have seen, but there's been news articles. We're starting to see research happening out in the field. And so this is a really important conversation. It can feel quite, at times, contested, depending on who you talk to. But we're going to talk through a lot of those issues today. The next 2 parts of this series are going to actually talk more about carbon removal and ways to do that. We're going to talk about carbon removal at scale for part 2 on June 17th. Right here, same time, same place. Not the same time as in the day, not same time of the month. And then for part 3, we're going to talk about carbon removal here in the backyard of Colorado and what is happening there. But we're going to start here talking about looking up and talking about that incoming solar radiation. So I have 3 amazing people sitting here on stage with me. Their bios are on the table. I'm not going to read their lengthy bios, and they're even more extensive than what's on the table there. I encourage you to Google them. But I do want to say that collectively, you're going to see why I have brought this panel together. They are extremely thoughtful people. They collectively serve and lead and co-chair national academies panels on this. They are presidential appointees. They are podcasters and teachers and thought leaders. And you will quickly realize why they're having this conversation today with me. But most importantly, I think they're very thoughtful humans. And when you have these conversations, it's really important to have thoughtful humans up here on stage, especially on this topic. So the gentleman sitting at the far end is someone who you're actually going to get to see through all 3 parts of these series. I'm really grateful to have gotten to work with him here quite recently to put this concept together and bring it to life. This is Will Burns. Will is the co-director of the Institute for Responsible Carbon Removal at American University. He is also a visiting professor in environmental policy and culture at Northwestern University. He flew in this morning from Chicago. I have been following your work for a very long time. And he is a quite leading expert and sought after in many ways in many of these topics. And he is our partner in this series, and he'll be here with me for all 3. So thank you so much for being here this morning, Will. And sitting next to Will is Lisa Dilling. Lisa has been a longtime friend and supporter and partner of ours here at the Institute. She is well known here in Colorado if you've gotten a chance to work or meet her. She's this great social scientist who used to be with the University of Colorado Boulder, but she has here somewhat recently now, spent more than a year, has it been? About a year. She's with the Environmental Defense Fund. She is their assistant chief scientist with EDF. And also here is sitting right here next to me is this lovely human who I actually just got to meet somewhat recently for this series, Suchi Talati. She is the founder and executive director of the Alliance for Just Deliberation on Social Geoengineering. This is her life to talk about this work, and we are going to have a lot of good insights from her as well, too. So let me flip forward to that, which was everyone's title. I think I can't see the slides myself. And then if I'm on the third slide, which I think I am, is just to let you all know that this is how you're going to ask questions. I'm on slide 4, so I need to go back one. Okay, that's the slide. There we go. Thank you. Slide 3 right here is a QR code if you want to scan that, as well as a link. If you want to ask questions through today's panel, I will keep my eye on them and try to incorporate these questions into our conversation. You can upvote someone else's question, but definitely feel free to engage with us this way throughout today's talk, and I will work to make sure we get those incorporated in the conversation we have here as well. And I'll leave this up throughout most of the thing. Alrighty, so I'm going to kick us off. We're having each of our speakers share a little bit more about this topic to just kind of set that ground stage level understanding, and then we're going to start to unpack. So actually, I'd love Lisa to start to talk a little bit about some of the mechanisms. Specifically, what are those main solar geoengineering mechanisms that we're talking about? What is being considered, and how do they differ? Give us that landscape view of the science that we understand.
Sure thing, and thanks so much for that introduction and for having me here on this panel. This is really fun and exciting to be here. So I'm going to, as Kristen said, I'm going to introduce a little bit about the technologies, just a couple minutes to give you a flavor. So today we're talking about solar geoengineering or solar radiation modification. This idea really comes fundamentally from the observation that when a volcano, a really big volcano, goes off in the world somewhere and spews all this dust and ash up into the stratosphere, we actually observe a little bit of a cooling around the world for even a year later after that big volcano. This is for really, really big volcanoes. So when scientists started to notice this, that there was actually this cooling effect from volcanoes, it also happens, I was just talking at the table, from lower ground air pollution. Air pollution particles also can cause a little bit of a cooling effect over cities. So these particles in the air can reflect sunlight. So, global warming, climate change as we know it, is caused by an increase in greenhouse gases in the atmosphere. This buildup of greenhouse gases traps more heat in the atmosphere. So this is what we're actually all working on, right, is trying to remove greenhouse gases, trying to mitigate climate change. That's our number one job. We're talking here about kind of a totally different thing, but our number one job is really climate mitigation. But that's dealing with greenhouse gases. This idea of solar radiation modification is really thinking about tackling that temperature head on. So thinking about putting particles up into the atmosphere that would reflect a little bit of that sunlight and cool the earth a little bit on a deliberate basis. So the different ways that that could be done are sort of mimicking a volcano, which would be to take a fleet of aircraft, a big aircraft, a bunch of aircraft, not like a little tiny plane, but a big, huge bunch of aircraft that could make it up to the stratosphere, which is one of the highest levels of the atmosphere, and dispense these particles to try to reflect sunlight back into space and cool the temperature a little bit. Another idea is called marine cloud brightening. So there you might have noticed, obviously, when you walk under a cloud on a sunny day, it's a little bit cooler. Well, could we brighten clouds a little bit more, make them a little bit whiter so they reflect more of the sunlight back into space? That's another idea. Notice the theme here is we're really trying to work with the reflectance of the planet, trying to reflect heat back into space so that it's not accumulating as much here on Earth. There's a few other ideas that aren't as well researched yet, which are things like cirrus cloud thinning. This would be trying to break apart very high clouds that actually prevent heat from leaving. So if you break apart those clouds, you let more heat escape into space. There's also a relatively new idea that I've just heard has gotten a little bit more legs, the idea of a giant sunshade. So you might, this is sort of sounding a little, I know, like science fiction, but there are actually people out there with companies starting to think about this. And the idea of a giant sunshade is to put just like it sounds, a kind of a big fan at a certain point between the Earth and the sun and reflect a little bit of incoming solar radiation through that sunshade. Now, I should say right now, none of these things are being done. None of these things are actually happening. They're very much on the little napkin on your table stage, or in some cases are researched quite heavily. I'd say the first couple, the stratospheric aerosol injection idea of putting aerosols up into space with into the stratosphere with airplanes, that one has been researched heavily. Also, marine cloud brightening has quite a bit of research behind it. So those are the kind of things. There are a few other ideas, smokestacks, tunnels, different things like that. Even things like painting roofs white. You might have heard of that idea. The issue with that is it's not really scalable to, it's good for local cooling, like in a local area, but it doesn't really do the job for a global cooling effect. But I think that's probably a good overview for now.
Great, thank you. Well, so talk to us a little bit about the why. Why do we do this? What are some of the potential benefits as well as the risk to doing this sort of technology, i.e. both sides of that coin, the pros and cons?
Thank you. So there's two primary reasons that we're thinking about solar radiation modification. One is to buy us time as we try to decarbonize the economy and not pass critical temperature thresholds, right? We think we have a budget in terms of the amount that we can emit of carbon that will, in 10 years, result in temperatures increasing by about 1.5 degrees Celsius from pre-industrial times. And there'll be very serious manifestations of climate change as a consequence. We're already seeing manifestations at about 1.1 degrees Celsius, but 1.5 gets more serious. We probably have a budget of about 20 years to exceed 2 degrees Celsius, and then things get very serious, and we start seeing all kinds of nonlinear sort of responses in the climate. And so one of the ideas is that cooling the stratosphere or utilizing marine cloud brightening to reduce the amount of incoming solar radiation would buy us time as we try mightily to decarbonize the world's economy and not pass those critical thresholds. Because when we pass those thresholds, a lot of the impacts that we would see could be irreversible, right? So we want to avoid that. The other rationale which is related to that is if indeed we do pass those thresholds, we could use this in a so-called overshoot scenario, right, where we try to bring temperatures back down below those critical thresholds to avoid ongoing severe impacts associated with climate change. There are risks associated with these approaches, however, and a lot of those risks are marked by high uncertainty at this point because, for the most part, when we look at these approaches that Lisa described, we've primarily done this in terms of modeling, right, which means that absent field research, extensive field research, right, we're not certain. But some of the risks that are discussed in terms of sulfur aerosol injection, this idea of putting sulfur dioxide in the stratosphere, there's worries that it might alter the hydrological regimes, so it might result in less precipitation, especially in places like Southeast Asia where it could potentially imperil the monsoon, and that would obviously have huge implications in terms of agriculture. There's concerns that sulfur dioxide injection would accelerate the breakdown of the ozone layer because it would create new foundations for the chemical reactions in which the chemicals that we put in the stratosphere that break down the ozone layer could accelerate that process. We're also concerned about something called the termination effect, which is if you start utilizing this and simultaneously are not really aggressively reducing your carbon dioxide emissions, you'd have buildups of carbon dioxide in the atmosphere without really feeling the impacts. But if you ceased using this approach, you could have very rapid and very large pulses of warming, which would make it very difficult for both human institutions and ecosystems to adapt. Marine cloud brightening could alter precipitation regimes also. It also, by cooling the oceans, could have impacts in terms of net primary production, things like phytoplankton, for example, and fish, and biogeochemical changes. The space-based approaches also potentially have some implications, but highly uncertain at this point. Mostly our concerns in that context are costs, which would be, as you can imagine, very, very large. And I'll just stop there.
That's great. Yeah, a lot of trade-offs to be unpacked here as we go forward. So Shuchi, talk to me a little bit about the conversations that exist, both nationally and internationally, around both the sort of deployment and governance frameworks that exist to date.
Yeah, thank you so much. And I just want to say thanks for having me. A museum is such a great venue for having more conversations about this. So thank you all for joining. So I want to start by saying, for the last 20 years, this has been a really taboo topic. It's been really hard to have conversations about it. It's been very limited, with very few even climate policymakers wanting to engage in this conversation. That has started to shift significantly over the last few years. We've seen a lot of increased interest in growing research and also a lot more interest in thinking about governance regimes. This is largely happening in the global north, so in places like the United States and in Europe. But we are starting to see more international institutions willing to talk about this as well, which is incredibly important for technologies that will be globally impactful, right? These technologies are large scale by design. So there's no way for these to be focused on any sort of local community. They will have global impacts. And so we need the most vulnerable communities, those that will be most impacted by climate change, but also most impacted by use or non-use of SRM, to have a seat at this table. So just kind of a few things that I want to point out that have been happening over the last couple of years. I think first we've seen a huge media increase in attention on this topic. You've probably all seen articles in places like NPR, the New York Times, major outlets starting to talk about this in very noticeable ways. And I think that's happening, for a few different reasons, right? We're seeing more climate impacts. There's a lot more conversation about the fact that we have unfortunately done not enough on this topic. And I think the idea that we don't have enough invested in adaptation and there are some impacts that are unavoidable, could SRM be a potential idea that could limit a lot of that harm? And I think that's why we're seeing a lot more conversation. I think one thing I want to point out here is that I think the reason I work on this topic, and I think my co-panelists do as well, is that SRM is an idea that could have that potential to limit a lot of human suffering. But at the same time, it could exacerbate it if we don't have more equitable conversations, if we're not thinking about the how, the who, and the where. And so in this increased media attention, I think a lot more of these conversations are starting to come to the fore. We're also starting to see a lot more governments interested in engaging in conversation, which hasn't been the case for a long time. So for the first time, the White House released a research agenda last year. We're seeing places like Europe, the European Union released a scientific memo that raised the importance of governance and national security concerns. And we're starting to see conversations in places like the UN. And so just this year, a few months ago, the UN Environment Assembly, which happens about once every 2 years, actually discussed a resolution around solar geoengineering, just thinking about how to bring together an expert group on building an assessment with more participation. I went to those negotiations and was very surprised to see so many countries wanting to engage in that conversation, which I view as a really, really good and important step in moving this conversation forward with more people engaging in that. There were a lot of different things that people wanted, and the resolution that was proposed wasn't passed. But there is so much interest in a lot of different countries in starting to engage. And the last thing I'll mention is the private sector. We're starting to see increased engagement from companies, for-profit companies, engaging in solar geoengineering. Personally, I view this as very problematic. I don't think you can have a for-profit arm for something that we have massive uncertainty around and could cause a lot of harm. And at the same time, we don't have sufficient regulation to stop or limit what they're doing. We have no national or international regulatory regime for solar geoengineering because we've been avoiding this governance conversation for too long. And so a lot of these companies are having the opportunity to function in a space that is effectively not regulated. So I'll stop there.
Actually, I want to pick up right there. Let's move that conversation. You brought up the idea that we are seeing private companies come into this space. So what does that funding looked like both historically and where are we seeing it today, right? This stuff originally has been both basic research coming out of the research community, the scientific community. As most scientific technology advances, it starts to get more into that applied realm, and we start to see companies kind of step in, right? So funding, where is that coming from in addition to private companies? What sort of government, and the US included, has been funding this, and where are we in that funding conversation? And Suchi, why don't I start with you, and love for all of you to chime into this conversation about funding and who's doing some of this potential deployment.
Yeah. So we've seen very limited funding in this space. Over the last few years, it's been a drop in the bucket compared to funding for broader climate research, for funding climate from the government perspective. But starting in 2020, the US started funding research at a level of about a few $1 million a year. It's about $10 million a year now. But from the perspective of organizations that are working in the space, like nonprofit institutions, funding largely comes from climate philanthropy. So foundations that have funded all the kind of environmental organizations and nonprofits that you see in the space. But it's been really challenging to get funding to work on governance. I think traditionally in the climate space, you see funding go pretty quickly to research and to climate tech. But I think SRM is markedly different than any other climate tech that we've ever engaged with before. And so thinking about governance and thinking about how the space moves forward, I think is actually quite different and quite important to shape at this really early stage. So that funding has been more challenging. And I think the last thing I'll say is we've seen some funding from a few different other countries in research. So China had a research program up until last year, from 2016 to 2023. We've seen some early research funding in India. We now have, as of a few months ago, the UK has announced, I think, about a $10 to $15 million a year research program, and Canada has signaled interest as well. So it's starting to shift pretty quickly. And the last thing I'll mention is that the private sector is stepping in, but so far it's been pretty small. But that could change really quickly. And the reason I think that's really important to mention is that one thing we haven't said so far is that deploying these approaches could be quite cheap, relatively speaking, right? To deploy something like stratospheric aerosol injection could cost as little as $10 to $15 billion a year. And so comparing that to decarbonization, which is a multi-trillion-dollar effort, a few funders could effectively change the space very quickly.
I think that was a pretty comprehensive overview, but I agree with the point about the relative inexpensiveness, if you will, of this technology. Maybe not the space reflector, but the SAI. It's true, and that is not to say though that we have it available right now. It still would take a decade to build up the capability to deliver these the aerosols to the stratosphere. But it just points to the need, I think, for governance as well. Like that's been very, very absent, very lacking internationally.
So let me ask then, great, well, I want to come back to more governance, but we had some questions around some technology pieces that I think we probably want to cover to establish some more baseline understanding, which is, so first of all, I had the one about the sunshade, Lisa, that you brought up. What is that?
Well, I don't know. Will might know more about this, but it's the idea is that it would sit at the, what's that point between the Earth and the Sun?
The Lagrange point.
The Lagrangian point, right in the sweet spot, if you will, between the Earth and the Sun, and it would be like a giant fan. Imagine this fan kind of opening, and I should say this is like one company's idea, so really you should get them over here sometime to talk about their idea, but what's interesting about this idea is in the past it was seen as really expensive, but now that we've discovered water, like liquid, not liquid, but ice on the bottom of the moon, and that has the potential to create hydrogen and possibly an energy source, therefore, there is the idea of putting together this idea of mining the moon for hydrogen or for an energy source, and then being able to service or put this sunshade up in space and have sort of a platform from the moon to be doing it. So it's, I mean, think about it as if you put a parasol over yourself on a hot sunny day, or if you put over your pool, you know, you put a little umbrella out there. That's literally the idea. It would sit in this point between the sun and the earth where it would just catch a little bit of the incoming radiation and have it be just a little bit less intense coming in. Now, as you can imagine, and again, I'm not an expert on this technology, but there's a lot of ifs and what in that kind of statement, you know, because how do you know how much you'd adjust this sunshade? I mean, what if it went too far and really made it like a big ice planet? You know, there's a lot of questions about what that actually would look like. I don't think it's been researched as much. So this question about private actors is really important for this particular technology, because they've got a for-profit arm, I believe, and then a non-profit arm, which would be the Sunshade, which they are trying to do it as a non-profit. Anyway, but these are, you know, this is sort of innovative space right now, where people are just coming up with ideas and trying to think of how this would work. But that's what the sunshade idea is. But maybe Will knows a bit more.
Can I just make a comment? It's like the solar eclipse, right, that we all just experienced in essence, right, where we physically felt that temperature decrease.
Exactly.
So, Will, what else is there as far as, we also had a question regarding, are there other particulates that could be used for the process besides the sulfur? And then if you could also, if anyone knows, Will, maybe you start and others. Another question here was, how much actual energy do we need to potentially be reflecting back into space?
I'll start with the energy one. The answer in terms of how much you have to reduce what they call insolation, right, incoming solar radiation, is dependent on what results you want. So rule of thumb is if you wanted to return temperatures back to pre-industrial levels, right, before we started spewing all these greenhouse gases into the atmosphere in the 1700s, you'd have to reduce incoming solar radiation by about 1.8%, right? Now, if you only want to hold temperatures to where they are now, right, this idea of buying us time, right, as we decarbonize, or hopefully decarbonize, then you could reduce that amount, right? And so the interventions could be less, right? So it's dependent on what your objective is. In terms of the space, Elon Musk has an idea to actually shoot dust from the moon to reflect incoming solar radiation back to space. And there's ideas of creating huge amounts of mini space frisbees that would be highly reflective and putting it in this in orbit. So there's a bunch of these ideas. I think another risk of this is, remember we talked about this termination effect, right? If you ever ceased using this technology, you'd get a very large pulse of temperature and very rapid. One of the problems with space, of course, is space junk, asteroids, right? And And if you didn't have a redundant system and you wiped out the protective umbrella, right, you would get that termination effect, right? So I think that's another peril, right? And we're also developing, of course, anti-satellite missile technologies now that a country could potentially use and hold the world hostage by saying we're going to usher in the termination effect by shooting that parasol down. So I think there's a lot of security issues associated with space.
And any other particles being considered besides sulfur?
Oh, yeah. So there's a couple others that are being talked about. One is titanium. One of the reasons that titanium has been discussed is that it could potentially reduce the threat of ozone depletion that we talked about, and that's a very large threat. Some of the studies say that if you deployed this at a really large scale, you potentially could have ozone depletion that was commensurate with what we had in the 80s, which was really the peak of ozone depletion associated with these ozone depleting substances that we used to have in things like hairsprays and deodorants, and we also use in air conditioning units and things of that nature, fire extinguishers. The idea would be that titanium could potentially reduce those impacts, but we just don't know. There was a recent study that indicated that it could exacerbate it, right? And that's the point. We need a lot more research in this context. And then there's also been proposals to put diamonds in the sky, right?
The other one I'll mention is calcium carbonate, which is a very common substance that we have everywhere. And that one I think has actually a lot of focused research right now.
Yeah, the Diamonds in the Sky one has been, I feel like that's a great title for a book or a podcast or something, putting diamonds in the sky. Okay, so I want to take you all big picture here and talk to me a little bit about these ethical considerations that we have when we start thinking about deployment. So what are these ethics and values that we should be thinking about? Because you've mentioned a lot of these sort of impacts, who has a seat at the table, who are making these decisions. I would be curious how you all have thought about where are the ethics thus far when we talk about actually getting to the point of deployment for some of this? Looking whoever wants to stare at me first. Lisa.
Well, I suspect Sushi has a lot to say on this one. I'll just start quickly saying I think that the issue, because this is a global intervention, I mean, we're talking about a global intervention here. To me, this brings up immediately the ethics of who gets to decide. Who gets to decide what's happening? I mean, we're here in this country having this conversation right now. We have researchers in this country, leading edge researchers studying this. We might have a lot of knowledge within a short hand throw, a couple miles here actually. But that's not the case everywhere. And a decision like this is going to have winners and losers. The decision to deploy any of these technologies and try to cool the planet, it's not going to be a uniform, just dial down the temperature and see kind of in a uniform, easy way. It's going to have regions that do different things that we're not expecting. And I believe, this is my own ethical principle, is that people need to be engaged in all countries around this, because this is actually not something that's just going to affect one part of the world. I also feel that there's a lot of unintended consequences potentially with this. I come from biology a long time ago, studying biology, and we just have so many examples of let's introduce this species, it'll be so great, and then Australia's overrun with rabbits, or New Zealand's overrun with stoats or something. And I feel like these are, while we're weighing risk here, there are unintended consequences that we need to be thinking about. So to me, there's just, the ethical issues are very fraught and very difficult, and I think so I guess so one of them is the participation, but the other is things like transparency. In my organization, we just hosted a workshop a couple of months ago to think about, well, what are the ethics of doing research? What are the governance principles that we might need just for doing research in this space? And one of the big principles we talked about was transparency. If this is something that we are starting to study in earnest, which we are already studying, but if we are starting to study it with an eye toward making a decision about it, we need to be really upfront about that and be talking about this as a real subject. And I believe that we need not just the researchers involved, but governments involved, the public involved, people who are going to be weighing in on what kinds of solutions or I shouldn't even say solution, but what kinds of types of interventions are going to be acceptable. So I'll just say those few things, and I know others have big thoughts on this.
Thanks, Lisa. No, I agree with everything Lisa said. And one thing I want to add for the transparency piece too is, this is something that will affect everyone, and I think should happen in an open way. And I think one of the challenges there is that, military involvement or private sector involvement could limit that. And so my own personal ethical concern is that this will happen in the dark. And I think to have public participation and to have public input, I think is necessary for the space to have legitimacy. And I think it's really important for us to think about this at these early stages when we can build that into the field. The other thing I'll mention is I think, climate justice is kind of at the core of this for me. And I think, there are two ends of the spectrum that I think are kind of very much battling it out right now. I think there's one far end of the spectrum that thinks even talking about soil geoengineering, even raising this idea is problematic and unjust. And then you have the other end of the spectrum that's saying, without this, we're going to see a lot of harm and suffering. So we have to deploy this to save the world. I think both of those things right now are unjust because they're not involving the people who sit at the center of vulnerability and impacts. Right now, we don't have enough information, we don't have enough participation, and so to limit this conversation to those that are privileged to have access to knowledge is not fair. And so when I think about kind of the ethical considerations, I think right now the core of that for me is democracy and democratizing knowledge and access to this conversation. Making sure that people even know that this conversation is happening, which I would say the vast majority doesn't, even in the United States. And so we have to make sure that we're really thinking about how we make sure that people have access to this information, and then beyond that policymakers and researchers have access to resources to answer questions that they have that we might not ask in the United States or in Europe, right? We have to understand what questions around impacts or human and social systems people have so we can actually think about funding the research to answer those questions. So I think the last thing I'll say there is that it's not just about kind of the use or non-use of this technology, but I think ethics really lies in how we're actually getting to those answers and who's part of that. I think Lisa said who's getting to make this decision, and I think that's really really challenging. And I think the reason I think it's even more challenging for SRM is because it's just the total opposite of any other type of technology, right? It's potentially very fast acting, it's potentially very cheap, and so an actor could move unilaterally on this in a way that they could not for any other type of climate technology. And so this who actually becomes a really powerful question in a way that we've never actually had to deal with before. So I'll stop there.
Will, would you add anything to the sort of ethics and values conversation around this?
Yeah, so I agree with everything that the Suji and Lisa said. So I'll just focus on one specific thing, and that's going back to this termination effect idea. I think an ethical consideration is if you implemented a solar radiation management program at scale, you would have to keep it in place potentially for, according to the National Academies of Science, as much as 1,000 years, right? And so there's all kinds of ethical considerations, I think, in imposing that kind of governance for that long a time and assuming that we'll have viable governance for that period of time. But the other thing is that because you would potentially face the termination effect if you stopped using this approach, you essentially would be requiring future generations to keep that program alive, no matter what manifestations it might have that they might deem unacceptable, the alternative of simply stopping the use of that technology would be catastrophic. And so I think there's a question of what we call intergenerational equity. Does our generation have the right to create that sword of Damocles for future generations, and not just one generation, but many, many generations, right? But it cuts both ways, right? Because the argument that could be made on the other side from an intergenerational perspective is, given the fact that our generation and my parents' generation have visited potentially catastrophic climate change on future generations, and we now potentially have a technological approach that could help ameliorate that, is there a responsibility of this generation to future generations to research it and potentially deploy it, right? So it creates a very large, I think, imposing sort of ethical dilemma on top of all the other things that we were talking about.
Can I ask
Yeah,
add
please.
one
Yeah,
thing?
you
I just wanted to add one more dimension to the ethical dilemma, which I think we haven't touched on yet. Some folks are worried that, and this falls to CDR as well, which we'll talk about in the next two talks, but some folks are worried that if this becomes a real viable technology out there, that it might actually deter us from taking on really tough mitigation challenges. Now, I should say, first of all, I think we said this in the beginning, this is not a substitute for mitigation. This does nothing for the greenhouse gases in the atmosphere. They continue to build up, and as Will has said, termination shock is a real thing. It also does nothing for ocean acidification. So ocean acidification that is happening now as we increase CO2 in the atmosphere, that is going to continue to happen. So it's not a substitute, but some people might feel like, well, it's cheap, it's fast acting, maybe we're willing to take that, and then that takes the pressure off of the mitigation side. We don't know if that's really going to happen. It seems like some of the survey research, the social science research that's been done has said that actually when people hear about this topic and when you do, lay people are responding to surveys, they're even more committed to fast acting on mitigation. They do not see this as like something they want to jump into with both feet. So whether or not this worry about mitigation deterrence is real is a question, but that is something that people in this space, especially in this policy space, where it's very difficult, to bring down decarbonize our energy system. Some of them are very challenging to decarbonize in the time frame we need. People might start to be looking at this as some sort of like, well, we can put that off. So that's another, I think, ethical dilemma or worry out there about this becoming more of a talked about technology.
I just building on what Lisa said. I think something that's come up a lot in my work in this space, which has been for many years now, is isn't even raising this idea something that's really dangerous, right? We don't know anything about it, and from my perspective, I don't want to be talking about this. I don't think anybody wants to use solar geoengineering. It is crazy, but at the same time, we have failed at climate governance, at decision making over the last 30 years, and we're not funding adaptation. We're not recognizing the impacts that a lot of people are already feeling, and so we have to have the conversation now. It exists. It's not going away, and I think it's really important to remember that this is not something that I think makes sense in a climate vacuum, right? And it can't exist on its own. It can't exist without carbon dioxide removal, without mitigation, and without adaptation. It's not a solution. It's an approach that could alleviate some harm. And I think it's a really important ethical lens to view it through, because it's not something that I want to be here talking about. I wish that we had made different decisions 30 years ago that wouldn't have led us to having to raise this as a topic. But even if we were to hit net zero tomorrow, we will see climate impacts for the next several decades. And we're not engaging in that conversation the way we should be.
Let me bring up this concept you brought up just a little bit ago, Suchi, about unilateral action. A number of years ago, maybe like 8 or 9 years ago, I chatted with Ken Caldera, for many of you may know, who's another leading researcher and scientist on this topic. And I think I had floated with him that kind of hypothetical situation that many people had, which is X years in the future, some country, potentially perhaps even a developing country, their population is experiencing a massive famine, they're seeing extreme impacts, to their country and their system. And there's that political pressure for someone to act and to do something because of the sort of slow moving, in essence, disasters that we can see from climate change. And someone takes unilateral action to do this, right? That feels like could be a compelling case for a politician to make that decision where we are with understanding where this technology is getting to that point. So to try to understand where unilateral action could be reduced down, who is coming to that table more to have these conversations, and how is that political conversation shifting and changing, and where would you like to see it shift and changed?
Do you want to start?
Well, go ahead.
I will say, I think unilateral action is something that I thought about a lot, and we're starting to see in the stories, right? Kim Stanley Robinson recently released Ministry for the Future a few years ago, where India deploys solar geoengineering in the context of massive heat waves. I think we're starting to see more similar stories, permeate movies and stories, and so I think it's a really interesting topic, and it's plausible. I think there will need to be some sort of infrastructure that an actor has access to. It does cost some money, but at the same time, I don't know if we would have the moral high ground to say you can't. It's something that I grapple with a lot in terms of if someone were to make a decision about this in the context of complete lack of international treaties or regulation, would global North countries have any sort of platform to say no? And I don't know the answer to that question, but it's really challenging. I will say, like, over the last 2 years, as I mentioned, we've seen a lot of different UN institutions start talking about it, and I think that is extremely important. It hasn't been sufficient, and what the right UN body might be is still a huge question. The UN institution, the UN framework for climate, the UN Framework Convention for Climate Change, UNFCCC, which is the body that handles climate change, has not engaged with solar geoengineering yet. We have seen the UN Human Rights Council, and as I mentioned, the UN Environment Program start to talk about this. And I think that is what I want to see more of. What an international regime could look like has been the topic of a lot of academic research for a long time. I think those discussions will be very fraught and very difficult. But I think if we don't have those conversations now, I think we could see a lot of these different stories potentially play out in problematic ways.
Do you want to go on this topic?
I think my fear is when it comes to unilateral deployment, it's likely to be a really big, strong country that can't be stopped. I think if a smaller country, unless it did it really covertly, announced that it was going to send a plane into the stratosphere to do this, and the U.S. didn't want it to happen, or China or the European Union, we just shoot it down. I think, on the other hand, if the United States decided to do it, or China or the EU, they could do it, right? So there's my fear that ultimately this may be driven by one of the superpowers, right? And I think one of the real difficult questions when we talk about governance is, even assuming, for the sake of argument, that there's a body that's going to deliberate and decide, what does decide mean, right? Do we need consensus? Does it mean every country in the world says yes, right? Or is it a supermajority? Or is it the countries that would be most impacted? How do you determine what the decision-making apparatus is, and who ultimately decides? And I think that's going to be a very assuming we ever get to that point, it's going to be very difficult to sort out those issues.
Lots of still open-ended questions, hence why we're having this conversation discussion. We've got about 10 minutes left, and there's some other things I want us to talk about, and Lisa, I'm going to start with you on this, which is a little bit around this public perception piece, which you actually started about. Where are some of the public perception that we currently see, and understanding what we're talking about, either from a fear-based or from a, like, we need to do something, that two sides of those spectrums that Suchi mentioned, and any misinformation out there that you've seen that we should be kind of trying to like unpack ourselves and make sure we're aware of. Contrails comes to mind as one.
I was gonna say. Yeah, thanks. That's a great point. And so, number one, the public perception out there is very low on this topic. I mean, when you do general surveys in any country, I think, and you ask, do people know what this is, and you give them some prompts to even steer them in like what it is, people don't know what it is. It's very low salience among the general population. Once you do say deliberative studies, or you work with groups like focus groups around a table, and you start explaining what it is, I've done some of these groups myself. Once the nervous giggles kind of die down at the table, then people start to engage and they think, wow, this is serious. Maybe we should research this. That tends to be the reaction when you have a thoughtful conversation about it. Nobody's, at least in the research I've read, nobody's ready to go deploy this when you do, again, public surveys or public perception studies. There's also research about SRM. So what does the public want to see in terms of how the research community conducts itself? And I think it's really important to pay attention to those. When we talk about transparency and having input into a research process, that comes out of research and literature, because people want to be knowing what is happening, kind of what are the things who's controlling this research? Do they have any sort of say in how that research takes place, especially when you're talking about a large-scale experiment or something that would have an impact far beyond, say, a laboratory or a computer model. So people do have strong opinions about how research should be carried out. In terms of your comment about misinformation or conspiracy, okay, so this is an interesting part where conspiracy is meeting sort of what we're talking about here, which is there's a large community out there that believes that airplanes right now are seeding the atmosphere with chemicals, and they're called chemtrails. So, we see, when we look out the window and we see the clouds and the blue sky, and we see a line going across the sky, and we say, well, that's from an airplane, and that comes from, the exhaust coming out of the airplane and so forth. There is a not insignificant group of people who think that's a deliberate activity done by the government, and I'm not sure what they think the purpose is. Maybe somebody else knows, but it is something where they are already spewing out these chemicals through these paths of airplanes, and that is not a small community, and that is a vocal community, and that community has already weighed in heavily on this topic to say, I think they tend to be on the negative side, like,
Yeah, they want to stop it.
They want to stop it because it's like, well, it's kind of a bit of a jarring logic thing, but we're already doing it, but we should stop it or not do more of it. So there is misinformation that doesn't come from necessarily the actual topic, but that comes from something that happened even before. But that's the world we live in. When we talk about communication, we have to take into account those myths or those pieces of misinformation that are already out there, and that we must encounter. We must counter those pieces if we want to have an actual conversation about what we're talking about here, which is to try to control the temperature of the Earth. It does worry me personally that some of these techniques we're talking about do veer very close to what the chemtrail people have said is happening. That is a very, difficult, fraught situation, because here we are saying, well, we're going to consider doing this thing that this group of pretty much fringe folks have been saying we're doing for the last, I don't know how many tens of 20 years. So that really worries me as a narrative and as a when that starts to hit the fan in terms of thinking about this on a real basis. I think also something Shuchi mentioned about having this, I think you maybe called it a toxic conversation or just a very difficult conversation. I think groups like the chemtrail groups, but also just, you know, the way people react to this topic means that it is very difficult to bring forward these kinds of conversations in a democratic society because people already get such a visceral reaction, and it's very difficult to have a more sort of back and forth nuanced conversation. But we have to take into account, you know, the misinformation and also just lack of information and what's going to go into that void.
Can I just add one quick thing? Building on what Lisa said about chemtrails, I would say it's already hitting the fan. We have seen anti-chemtrails legislation pass from the state of Tennessee that was proposed by a legislator who believes in the chemtrails conspiracy that has passed both houses of the Tennessee legislature that is essentially now an anti-solar geoengineering bill, but isn't. And I think it gets to exactly what Lisa said, is that in you know, the way we talk about these things, it's not just either information or no information. I think misinformation will fill that void if we're not actively attempting to build public knowledge on this topic that is based in science. And we're already seeing other states pick up that same legislation. And so we also don't really have any organizations right now that are actively trying to educate state legislators in the United States. And you know, the focus of my organization is trying to build knowledge about solar geoengineering that is unbiased and scientific in climate vulnerable countries for civil society organizations, for policymakers. But, you know, this organization launched a year ago, and I think we need a lot more efforts and a lot more organizations coming to this space, willing to talk about it, willing to engage their communities in conversations that have good knowledge attached to them, because it's already very pervasive.
Well said, thank you. One silver lining, saw one of our state senators last week, and he was disappointed he could not be here today to hear this and told me to send him the video. So again, this idea of who's listening, who's paying attention, who's trying to understand that is really happening. And so hopefully our connections and sharing and being part of that, having these hard conversations will help add to that good work by all of you that you're already doing. Okay, we're gonna do lightning round real quick for some of these audience questions, and then I want you also all to end with a really short, like something, I don't want this to be a fearful panel, you know what I mean? We are pretty, like we talked about the skeptical elements of it, the uncertainty aspects of it, the risk of it, because it is a really hard thing. I also would love you all to tell me about that future look that you have for this. But we're going to do some quick lightning rounds. I may toss these to each of you individually to get some of these answered. One of these that I liked, maybe I'll start down here with Will with this one, and you guys can punt if you don't want to answer it. How would these technologies affect that solar energy generation, right? That is potentially a large piece of our energy resources for the near future if this were to be deployed. Is that potentially impacting all the solar deployment that we're anticipating?
Yeah, there's some limited research on that indicates that it may have an effect, but the good news is most of the research indicates that it's a relatively minor effect. So I think in the run of things, that's not a big concern.
Okay. Do we see growing support for geoengineering solutions because of some of the difficulties we've seen around both nature-based solutions and some of these hard conversations we've already had to decarbonize? Do we think we're going to start seeing more support for solar and other geoengineering technologies?
That's a good question. I think that there's a kind of coming together, basically, of the temperature trends, the impacts we're already seeing, and maybe some of the reality checks on the rate of decarbonization. I personally, though, honestly have a lot of hope about decarbonization. I can't imagine, like the things that we are doing now and the speed that we're doing them, the cost of solar coming down, the cost of wind coming down, the electric vehicle adoption rate, all of these different things. I have a lot of hope about that, but I do think that this conversation on SRM is coming up more and more because we're just not sure how we're going to make it, you know, like whether we're going to make it to the temperature thresholds or not, and sort of trying to look at we're giving this a second look, basically, the SRM. So I'm not sure that it's about, giving up on those things, but worried that it may not make it in time.
Many of y'all, obviously so, are understandably are skeptical of geoengineering. Who are some of the more critical thinkers pushing this approach?
So thinkers who are pushing the conversation forward?
Yep. Or the technology. Yep, both. Yep.
So I mean, there's a few very prominent researchers in this space that are trying to push research forward. A few names that come to mind are David Keith, Doug McMartin, Kate Rickey, and I think they're all doing different types of work. I think it's all important. A lot of most, if not all, is modeling based. A lot of it is social science research. Holly Buck is a really great social science researcher. I would highly recommend you look into all of their work. I think it's very different. They all have very different perspectives, and they bring different things to the table. I think there are some organizations that are starting to come to this space. EDF has been an actor in this space it was involved in early conversations. They've been a leader. My organization was launched last year. There's an organization called the Degrees Initiative that funds researchers in different countries to work on this topic. And so we're starting to see a lot of really amazing people come to the conversation about this. I think there are also a lot of people who are pushing back on this conversation at all in academia. There was a group of academics who released a paper a couple of years ago pushing for a non-use agreement. So a lot more academics also willing to have this conversation, which wasn't the case a decade ago.
Wonderful. Okay, we're going to do some closing thoughts here and wrap you all up. Thank you for joining us today. Dealer's choice, so you get to choose between the two. What's one thing you want the audience to either take away, something you said, something that you heard? What's that sort of one big takeaway that you want to leave people with? And or what's that thing that kind of keeps you working towards this future that we're all trying to work towards that feels better as it relates to this conversation? And whoever makes eye contact with me first gets to go. Lisa, yeah, go for it.
So, okay, I can't remember which choice this was, but I want to say that I've been skeptical. I mean, I've been on the skeptical side of this technology for a long time, and I'm still on that skeptical, cautious side. But I find myself looking at countries who are, and people who are suffering the impacts of climate change and thinking, what would I do in their shoes if I had a chance of this kind of technology? And so I think, it's not exactly something I think we should necessarily use. I feel like we have to research it. This is something we have to look into. But I have gotten a different perspective myself thinking about how would I be in someone else's shoes looking at this Earth, this planet temperature that we're facing right now. I do have hope, as I said, though, about the energy transition. And for me, that's where my source of hope really lies. It's not necessarily in the SRM space, but really in the fact that I believe in human ingenuity, in companies coming out with the fact solar panels, again, are so cheap. In the time I've been teaching as a professor, I have to totally redo all my slides about what's happening in the energy transition. So that is a really good, hopeful sign. We might still end up trying to turn to this at some point, but I feel like we have a lot of good momentum on the energy side.
I can go. No, I agree. I do have a lot of hope around the momentum and decarbonization, and I hope to see it continue. I think I have a lot of fear around the politics of the United States and the global politics and how that will affect climate choices. But I also have hope in SRM, not in terms of its use, but in that, I think we have an opportunity to do things a different way here. Solar geoengineering doesn't exist yet. And this might sound naive, but I don't think I could function in this space without this type of hope that maybe we can build something different, right? I think climate governance has been quite colonialistic. It's been fraught. I think it's been really challenging. And maybe we can start building a different foundation for this topic. And that's why I work in this space. That's why I built this organization, is to start moving that forward and to empower a lot more people, a much more diverse community to start being part of that conversation.
I guess one takeaway I'd reinforce is a need for public discussion of this, right? Given the profound impact that this could have for this generation and future generations, we don't want this decision being made by a technocracy or interested corporate interests or one country. It really needs to be a decision made by the world community and its citizenry, and that's a difficult thing to do, right? To get this on the radar of people, to get them to understand the science in an age where there's increasing badges of honor in not knowing about science, right? More than ever, we really need to understand the implications and the trade-offs, right? The fact that there's no free lunch at this point, right? Given what my generation, my parents' generation did to this world, we're going to have to acknowledge those trade-offs, but we need to be able to intelligently understand what those trade-offs are and how we weigh those and weigh in with our leaders to make these profound decisions that we may have to make.
Thank you. Join me in thanking my panel. Thank you all for joining us this morning. Thank you for those online who joined us as well. I think I threw a QR code up here if you all saw it. We really would love some feedback, survey work. So please take a moment to fill that out. Your feedback is really valuable in how we create programs and what we do next, and what you liked and what you didn't like. We're always looking to improve. I hope you enjoyed today. I did. Like I said, this is part of a 3-part series that we're talking about. This was the kind of the sticky, hairy one. And I said, we have to do this one first, because often I've been in so many conversations where this comes up, and it is multi-hours and days of conversations. You all did great in 1 hour. Next one will be June 17th on carbon removal at scale. We'll talk about both technology and nature-based solutions for that. And hopefully all of you that joined us here today will be back here next month for that one. And then we'll keep you posted on that third date. So thank you everyone for being here this evening. And thank you online. And thank you to all the wonderful staff and colleagues who helped bring this event together. Enjoy the rest of your day. Thank you. Bye-bye.